Dear students, welcome to the second SEM electronics class. This is your class on the operational amplifier, that is unit 1 in the linear ICs and digital electronics. This is class 6 on operational amplifier. So first, as usual, we are going to revise what we studied in the last class. In the last class, you studied about all the parameters. What are the operational amplifier parameters? That is offset voltage, offset current, bias current, differential input resistance, output resistance, capacitance, and the common mode rejection ratio and the supply voltage rejection ratio. These are the some practical parameters you studied. Okay. In today's class, we are going to study the CMRR and slew rate in detail. These are also what your parameters of the operational amplifier. In detail, you are going to study these parameters. Okay, so let us begin the class with the definition of the CMRR. So CMRR is abbreviated as common mode rejection ratio. CMRR is abbreviated as common mode rejection ratio. It is defined as it is the ratio of the differential mode voltage gain to the common mode voltage gain. It is defined as the ratio of the differential mode voltage gain to the common mode voltage gain. Okay, in this class you are going to study detailed about what do you mean by differential voltage gain and the common mode voltage gain in the next slide. Okay, before that we are having another two sentences here, that is CMRR is expressed in decibels. Okay, in the last week all of you have studied about the decibels. I think it is not necessary to explain here. Why we are going to use the decibels? Actually what happens, if the large number is there, then it is very difficult to write. That large number whatever is there, that in the compressed form we are using, that is nothing but what the decibels. Okay, that already you have studied. The decibel measures of CMRR is given by CMRR in dB is equal to 20 log 10 ADM divided by ACM. Okay, here I have given the one table for your understanding. If CMRR is equal to 10, what is its value in the dB? Okay, what is the value of CMRR in dB? That is equal to 20 log 10 ADM divided by ACM. What is this ADM by ACM? That is CMRR. If CMRR is equal to 10 means, how you are going to find 20 log 10 of 10? Okay, actually log 10 is nothing but it is 1. So that is 20. You are going to get the 20. Similarly, if our CMRR is 10 to the power of 3, then it is equal to 60. 10 to the power of 5, 100 dB. 10 to the power of 10 is equal to 140 dB. So now we will move to the next slide. That is, in this slide I am explained what do you mean by common mode gain and the differential mode signal. What do you mean by common mode signal and what is the difference of that you are going to study here. Okay, actually what happens, the importance of differential amplifier lies in the fact that outputs are proportional to the difference between two input signals. Thus, the circuit can be used to amplify the difference between two input signals or amplify only one input signal simply by grounding the output of the input signals are the defined as. So actually what they have explained here. So what is the importance of the differential amplifier means, in the differential amplifier we are using the two input signals, and the difference of that two we are amplifying, and if we want we can use the single also by grounding the other, that you studied in the differential amplifier. Okay, that is the one beauty of this differential amplifier. Actually that differential amplifier signals are defined as the common mode signals and the differential mode signals. Okay, the input signals what we are giving to the differential amplifier, they are defined as the common mode signals and the differential mode signals. What do you mean by common mode signals? So here by name also we can explain that common mode signals. Okay, that means the signals are common. In the electronics, how we are going to say that the signals are common means their amplitudes are same and the phase is also same. If the phase and amplitudes are same, then we are going to say that signals are called the common mode signals. Okay, when you are applying the two signals are of the same amplitude and same phase, then they are called the common mode signals. Okay, this I will show in the figure 1. I have drawn that. So what happens in the common mode signals, if you applied for the differential amplifier, that is not amplified. Why that is not amplified? Because in the differential amplifier what happens, the difference between the two signals is amplified. Okay, we have already studied. Differential amplifier is nothing but what? It is going to amplify the difference between the two signals. Whereas in the common modes, when you are applying the common mode signals means the difference is zero. So that is why it is not possible to amplify that signal. Okay, so what happens here in the common mode signal, V1 is equal to V2. In the common mode operation, always what happens, V1 is equal to V2 and difference of V1 and V2 is equal to 0. So that is why common mode signals is nothing but they are not amplified, that signals are rejected. What we are calling as common mode signals are rejected. Okay, let us hope all of you understood this one. Now I will show you the signals for the common mode signals. Common mode. What I told here, you see this is your V1 and this is your V2. V1 signal is of the same phase. This is called the phase. It starts from 0. This is also starts from 0. This is called the phase. Okay. This is, so here you see it, this is also starts from the positive side and this also starts from the positive sides. Amplitude is also of the same. So these types of the signals are called common mode signals. When you apply these two signals to the differential amplifier is nothing but what? The op amp also you can say. Otherwise you can say that in the I think in the second or third class we studied the circuit of the differential amplifier. It has the two inputs, V1 and the V2. Okay, if both are same means what it should amplify? Differential amplifier is nothing but it should amplify the difference between the two signals. So that is why what happens always in the differential amplifier, common mode signals are rejected. They are not amplified. Okay, now let us move to the differential mode signals. What do you mean by differential mode signals? Here By this also you can say that we are applying the different signals. Different signals is nothing but what? The phase is difference. Okay, here you see in the figure, here it starts from the positive and it starts from the negative. If the phases are different, then what happens? This amplifier is going to amplify that signals. Okay, so when the input signal to a differential amplifier are 180-degree out of phase and exactly equal in amplitude, that we have to remember. Amplitude should be same. They are called the differential mode signals. It is very important. Okay, the differential mode signals are amplified by the differential amplifier because the difference in the signals is twice value of each signal. Okay, its value is the twice the value of the each signal. For the differential mode signals, V1 is equal to minus V2. Always what happens? V1 is equal to minus of V2. That means opposite of that. Okay, now all of you understood what do you mean by the common mode signal and the differential mode signals. Okay, now we will move to once again definition of the CMRR. Okay, before that we will once again revise that. We arrive at a very important conclusion that a differential amplifier will amplify the differential mode signals while it is rejected the common mode signals. Okay, after reading the common mode signals and the differential mode signals, what you understood? You understood that common mode signals are rejected by the differential amplifier, whereas differential mode signals are amplified by the differential amplifier. Now let us once again the definition of the CMRR. What is CMRR is equal to? That is ADM divided by ACM, where what is ADM? ADM is nothing but it is the differential voltage gain, and this is a common mode gain. This is a common mode gain. This is a differential mode gain. Always what happens? This ADM is equal to open loop gain. So whenever I have written A is nothing but it is a open loop gain. Always the open loop gain is very high. And what do you mean? What is the ACM is equal to common mode gain? Always this common mode gain is equal to VOCM divided by VCM. What is VOCM? VOCM is nothing but it is a common mode output voltage, and VCM is nothing but what it is? Common mode input voltage. Okay, please try to understand this ADM and ACM. I think last class I have explained only ADM and ACM in detail. I have not explained, so that is why I took it once again for the explanation, that ADM is equal to open loop gain and ACM is equal to VOCM divided by VCM. This is output common mode voltage and this is what your input voltage in common mode input voltage. Okay, next, what is the importance of CMRR in the operational amp? It is very important point. Okay, if the higher is the CMRR, better matching between the two inputs. That means if CMRR is high, then we are going to call it as a one good operational amplifier. Okay, so what happens if the CMRR is high? Means it implies that inputs of the two operational amplifier is in good matching. Okay, if it is in good matching means what happens? It amplifies properly. Okay, input terminals and smaller the output common voltage gain. Always what happens? Smaller the common mode voltage gain is there. So actually for the 741 IC what happens? The CMRR is 120 dB. Because of that 741 is a one popular linear IC. Now actually here I have given the three problems for this CMRR. So just I will read and I will show you. But what you do means, please write the problem, write the given things and try to solve. Are you able to get these answers? Okay. If you are not able to get, then you just comment me. Okay. So first let us see what are the things given. A certain differential amplifier has a differential voltage gain of 2000 and a common mode gain is 0.2. Determine CMRR and express it in dB. Okay. What is CMRR? CMRR, for this first you should write the given things. What are the given things here? A certain differential amplifier has a differential voltage gain of 2000. That means differential voltage gain, that is ADM is equal to 2000, and a common mode gain, that is ACM is equal to 0.2. First let us determine the CMRR and afterwards that CMRR is expressed in dB. Okay. So in your notebook first write the given things, next try to write the solution. We know that, we know that CMRR is equal to ADM divided by ACM. ADM is equal to 2000 and ACM is equal to 0.2. Find out its value. And in the previous slide only, just now we have studied how to mention the CMRR in dB, that is 20 log of CMRR. 20 log of CMRR is 10,000, so it is equal to 80 dB. Please remember students, whenever you are doing the problems, write the units. For the units you are going to get the 1 marks. If you have not written the units, even though you got the correct answer, you are going to lose the 1 marks. Okay, I think all of you followed this problem. Second problem. A differential amplifier has an output of 1 volts with a differential input of 10 millivolts and an output of 5 millivolts with a common mode input of 10 millivolts. Find the CMRR in dB. As usual, write the given things. Next, find the, so here first we have to find the differential gain. Differential gain is not given, common mode is given and CMRR is given. So just you divide it, you are going to get the 100. Similarly, ACM is equal to 5M divided by 10M, that's equal to 0.5 common mode voltage gain. Find out the CMRR in dB, that is 20 log 100 divided by 0.5 equal to 46. So here what happens, directly ADM and ACM is not given. Using the formulas you have to find out the ADM and ACM. After finding the ADM and ACM, you are going to find the CMRR and that is converted into dB. Okay. Another one problem is there. Just the little bit difference is there. You do one thing students, you take this problem, try to solve that problem. After solving, go and see the problem, is it correct or wrong. Okay, I am not going to explain you, please try to do yourself. Similarly, I want to explain this slew rate once again. What is the slew rate means? The slew rate is nothing but it measures the how fast the output voltage can change and is measured in volts per microseconds. The slew rate of the op amp is nothing but it is a measure of how fast the output voltage can change. Okay, what slew rate is nothing but how the output of the operational amplifier, how fast. Actually, if slew rate is more, then that is called a good operational amplifier. If slew rate is more means you are going to get the fast output voltage. That is the meaning. How fast the output voltage can change. So this is actually it is measured in volts per microseconds. Okay. And for the 741 operational amplifier, slew rate is equal to 0.5 volts per microseconds. It means that output from the amplifier can change by 0.5 volts every microseconds. For 1 microseconds, output is going to change 0.5 volts. Since the frequency and is the function of time, the slew rate is given by Dout divided by dt. It's the formula for the maximum voltage. Okay, slew rate is defined as Dout divided by dt. For the 741 IC, its value is equal to 0.5 volts per microseconds. I already told here. Okay, let us hope all of you understood in detail the CMRR and the slew rate. These are the very important points for the operational amplifier, and for the examination point of view also, just you go through the formulas. Okay, some problems may be asked using the slew rate. Okay, just I have taken the problems from the VK Mehta book. Similarly, you follow the Gaikwad book for the problems. Do more problems on the CMRR and slew rate. Okay, these are the reference books. This is my concern about my students. Okay, meet in the next video.